Morning. Am I audible to you guys?
Yes, ma'am.
Okay. Okay. So today we will see how we can represent graph. Okay. Let me just share my screen. Okay. So we can represent graph in two ways. Okay. So there are two representation. One is adjacency matrix and other is the adjacency list. So what is adjacency matrix? It's just a m by m matrix. M will be your number of nodes. So if there are three number of nodes, there the representation of that matrix or the size of that matrix will be 3 by 3. If your graph has total 10 nodes, then the size of that matrix will be 10 by 10. So based on the number of nodes, your matrix will be formed. So what happens in this matrix? So if there is any edge between two nodes, it will just set the value of the matrix to be 1. Otherwise, it will be 0. Okay. So in this case, you can see from 0, there are three adjacent nodes. Okay. From three adjacent nodes means there are three edges from 0 to three nodes 1, 2 and 3. So when you represent a matrix or create the matrix, the value for this will be 1, 1, 1. From 0 to 1, there is 1 edge, so value is 1. From 0 to 2, 1 edge, so value is again 1. From 0 to 3, it's 1, again it's 1. Okay. Now, this way you will just see your number of nodes. Then again from 1, that means node 1. So between 1 and 0, again there is node. This is an undirected node, undirected graph. That's why your edges are bidirectional. Means you can move through and forward, back and forward, both sides. So therefore, we will again consider the same edge between 1 and 0 as well. So for node A1, two adjacent nodes are there. One is 0, another is 2. So the value between 1 and 0 will be 1 and 1 and 2 will be 1 and rest will be 0 because there is no connection from 1 to 3 or 1 to 1 because there is no self loop. If there is a loop there, then the value for 1 1 will be 1. Okay. Now again come to node 2. From node 2 there are two adjacent nodes again 0 and 1. So the value from 2 and 0 will be 1 and again from value 2 to 1 will be 1 and rest will be 0 because there is no edge between 2 and 3 and, no self loop. Okay. Then again same thing from 3 there is just one node, one adjacent node which is 0. So the value is 1 between 3 and 0. Okay. This is for undirected graph. Okay. Let me show you how. Is that concept clear? How we form the adjacency matrix? If there is H, there will be a value 1 in the matrix. Is that clear to everyone? Okay, if you say clear, then just let me show you. Okay, so this is your graph, and you need to create the adjacency matrix. You can say graph representation. Okay, so you need to, so what's the rule? You have to find out how many nodes. So how many nodes are there? 1, 2, 3, 4, 5. That means your size of the matrix will be 5 by 5. Yes, correct. So you just need to name it in the same way. Suppose the names are A, B, C, D, and E. Here also you have to write A, B, C, D, and E. Now you tell me the value. What will be the value here? Is there any self loop from A to A? No, right? So here the value will be 0. Is there any node from 1 to B? Yes, there is one edge. So value will be 1. Is there any node from A to C? No. Is there any connection or no edge between one A and D? Yes, so value will be 1. There is no edge from A to E, so value will be 0. Okay. So again come to B. Okay. Now from B, what are the adjacent matrix or adjacent nodes? A, D, and C. So you can directly write just A, C, and D. And since no H, the other will be just 0. Okay, again from C, only two adjacent nodes B and E. So you can just write 0, 1, 0, 0, and 1. Okay, from D, three adjacent nodes A, B, and E. So you just write A, B, and E. The value will be 1, rest will be 0. From E, two adjacent nodes C and D. So just write C and D and rest will be 0. Okay, this is your adjacent matrix. Okay, is this clear? Now is it clear to everyone? Dullar said yes. Dullar said yes. Okay, so this is for your undirected graph. Now we have another type which is your directed graph. So suppose I'm just giving age or direction. Okay, now I just provided direction to the edges. Now it's a directed graph. Okay, now if it is a directed graph, so what will be the matrix? The value will be different now, correct? You cannot consider this one, can you? Now from A, you see B and B both are not reachable. Only B is adjacent. Why? Because the H is going from A to B. Therefore, this one is correct, but this value will be 0 now. Why? Because there is no H from A to D. There is a node H from D to A, but no H from A to D. So you have to see from the node if there are outgoing edges or not. If there is an outgoing node to other adjacent node, then only you will write 1, otherwise it will be 0. Okay. Now B, from B, what are the edges you can go to? You can go to C and D. So you cannot go to A. Why? There is no edge from B to A. So now this value will be 0 and the only valid will be C and D. Okay. Now come to C. From C, there is only one edge from C to E. So this one will remain same, and from B you cannot go back. This value will become 0. Okay. From D to E you can go to only A. So this one will remain same. So rest you have to make 0, because from D you can only go to A, neither to B or E. So those values will be 0. Now from E you can only reach to D, not C. So only this value will be 1. So you got the difference now? If it's undirected graph, you have to consider it in both ways. From the both nodes, you can go to one node and again come back to other node. But in case of directed graph, you have to only follow the direction of the edge. If any edge is going from the source I'd say, from source, then or outgoing edges, then only he will consider it and write 1. Is it clear? The difference between the adjacency matrix of directed and undirected graph? Okay, Dular said yes. Will said yes. Okay, good. So remember there's another types of graph, which is your weighted graph. Okay. Now if I say there are certain weights for every age, let's say 4, 2, 8, 10, 5, 1. Okay. If you get an like weighted directed graph, then instead of 1, you are going to write the weight for that particular age. Okay, you are going to write the weight or the cost for that particular age. So instead of 1, you are just going to write the weight of the age from A to B. Here it's 4, so this value will be 4. Okay, from B to C the value is 2, so you are going to write 2 here. Okay, now from C, okay, I'm in B, so B to D the value is 1, it's 1, so it's okay. Now come to C. Okay, from C you can only go to A, E. It was 1 before, now it's a weighted graph. We need to write the weight of that particular graph, so I'm just going to make it 8. Okay, now for D, the only reachable one is 8, and I have to make it 5 because the cost is 5. Okay, now from E the value is 10, from E to D, so you are going to write 10. Is it clear now? We have seen we can represent a graph using adjacency matrix, and I have shown you all the three variants. What happens if it's an undirected graph? What happens if it is a directed graph? And what happens when it is a weighted directed graph? Is it clear? All three types for adjacency matrix. So only difference is undirected, write both for both the nodes. For directed, only consider the outgoing edges, and for weighted graph, instead of 111, you are just going to write the cost or the weight for that particular age. Okay, okay. So this is one type of representation. Then second type of graph representation is your link representation. Okay, it's called. Okay. So in case of link representation, it just uses an adjacency list. Okay. It's you can just think about your linked list. Okay. Let's just see the same graph. Uh, okay, first it's already directed, one is there. Now just go one by one. So, okay, so this is your undirected graph. So what happens in adjacency list or link representation? We make adjacency list. Okay, so here what I'm going to do, I'm just going to form a list or linked list for each of the nodes. So how many nodes are there? 5. So for every node, I'm just going to represent all the adjacent nodes. So first, suppose A. Okay, first node is A. So from A, I can go to B and D. So I'm just going to form a linked list. Okay, B. Then from, don't just get confused. From, it's not like from B to D you can go. It's just that from A you can go to B and D. Okay, there is no link here. Next is your B, node B. Okay, so from B, where can you go? A, D, and C. Okay, so you just need to write all the adjacent nodes from where you can go from B. Okay, it can be different. You can write A before, or you can write C or D. Sequence can be anything. Just that it's just representing the adjacent nodes. So it's not necessarily it has to be like A, D, C or A, C, D. It's not like that. Okay. There is no sequence. You can just write in any sequence. Just remember that all these nodes are adjacent to the node B. Okay. Next is your C. So for C, you can go to both. One is B and other is your E. Okay. Next is D. From D, you can go to both A and B and E. Three nodes you can go. B and E. Okay. So last node is your E. So from E, you can go to C and D. Okay. Is it clear to you guys? Adjacency matrix and the list. In case of list, you are just going to represent it in terms of your like linked list. You are going to consider one node, then from that node, what are the adjacent nodes? Adjacent node means if there is any nodes between two nodes, then those nodes are adjacent to the other node. Okay, is this one clear? Ma'am, explain once again. Okay, so you can see here in matrix we just wrote 1, 1, 1. In case of adjacency list, it just maintain for each node present in the graph, and it will store the node value and the pointer to the next adjacent node for the respective node. So if all the adjacent nodes are traversed, then you can just store none. Okay. So for A, what are the adjacent nodes? From A, you can go to B, you can go to D, correct? So you, instead of writing like in list, you are just going to make it as a linked list. Okay, from A, you can go to B and D. So if you see this linked list or adjacency list, you will know that for node A, the adjacent nodes are B and D. For node B, the adjacent nodes are A, C, and D. From B, what are the adjacent nodes? C, A, and D. Correct? So from B, you can go to A or C or D. Okay? This link is not showing that from A you can go to C or from C you can go to D. This is not the case. Okay? It might be a bit confusing because in linked list normally we go from one node to another, but it's not the case. This representation or adjacency list is only showing that from B you can go to these nodes only. Okay, and sequence can be anything. Here I have written ACD. You can also write CAD or DAC or anything. Okay, sequence doesn't matter. Just the thing is from B, the adjacent nodes are three nodes are there, A, D, and C. And when all the nodes are traversed, for the last node, you are just going to cross the node pointer because after that there is no unvisited nodes from B. Okay, so similarly, it's you can go to two nodes, both B and E. So you have just formed or store the value in the nodes B and E. Okay, this is the last. There is no other nodes. You can go from C, so you just cross the last node. So similarly, from B, you can go to A, B, E. Okay, so I have just written all these nodes. And for E, it's like this. Clear? Okay, ma'am, clear now. But LL indicator, it's a bit confusing. Just don't get confused. That it's not meaning that from A you can go to B, from B you can go to D, or it's not like from B there is an H to A, or from A there is an H to C, or from C there is an H to D. It's not the case. Just see the main node. Okay, it's just showing that these are the adjacent nodes for that particular nodes because first node is just a single node, not kind of linked list form. Okay, this is for your undirected graph. So if I make it again directed, what will be the values? Now from A you can go only to B, not to D. So in case of directed, I'm not going to write this one. Why? From A, there is only one node or one adjacent node, one outgoing edge. So there will be only one. Now from B, again, you can go to only C and D, not A. Therefore, I'm not going to write this one. Okay, so this one I'm going to cut it. Okay, now for C, you can only go to E, not B. So this node you cannot write. Okay, so only one node is reachable from C to E. For D, you can only go to A. You cannot go to B or E like undirected graph. So only one node will be there. Again for C, you can only go to D but not to A. So you just delete it. This. Okay, is it clear? So in case of both directed and undirected graph, you are just going to store the value of that adjacent node in the list. Okay, just the value of the adjacent node, or you can also say name of that node. Okay, name or data. Here it just written A, B, C, D. You can also write 1, 2, 3, 4. So accordingly, names will be 1, 2, 3, 4 and all. Okay, so this is for directed graph. Now, let's see what will happen for the weighted directed graph. Now, if you are using a weighted directed graph, that means you need to store both the name or the data for that particular name node and also the weight of that age. Okay, so now if I write 5 to like 4, 7, 8, 10. Now what you have to do? You need to just keep, means you need to store additional information. What's the value for that particular age? From A to B, you can go to B. Again, the cost for that particular age is 5. So you have to also write the cost for that age. Now from B to D, you can go 8. Okay, from B to D it's 8 extra. Then you can also go to C. The cost to go to C is 2. Okay, last is cross. From C you can go to E, but now we have extra cost, so you need to write that cost as well. Okay, so write just the cost of that particular age. Okay, from D to A there is an age from D to A and the cost is 7 or the weight is 7. You need to store the value of that weight as well. Okay, now for E it's 10. We need to write 10 and cross. Is this clear? Everyone? So we can represent graph in two ways, either using adjacency matrix or yes, X means null. Null means there is no unvisited nodes from that particular node. Okay, that's the last one. Okay, so there are two ways to represent your graph. One is adjacency matrix and other is the adjacency list. So in case of adjacency matrix, you are just going to write 1 or the value will be 1 if there is an age between two nodes. Okay, otherwise there will not be any 1. The value will be 0. Okay, then again you have to check whether it is directed, undirected or weighted directed graph. Okay, again if it is weighted undirected graph, the same cost you have to write for both. Okay, if it's undirected, you have to write for both in A to B and again in case of B and A. Okay, since it's a directed graph, I just wrote the cost directly between 1 to B. Okay, so always check whether your graph is directed or undirected graph. Okay, so if there is an age between two nodes, the value will be 1, otherwise value will be 0. And in case of adjacency list, we just store the adjacent nodes in the form of linked list. Okay, so here all the adjacent nodes will be stored in form of like linked list, but just don't get confused if one link is going from one to another. It's not going like that. From B you can go to C. It's just only representing all the adjacent nodes for the particular node. For A, adjacent node is B, and here for B, the adjacent nodes are C and D. Only see the outgoing nodes, outgoing edges, sorry. Is it clear? Okay, so can you tell me which one is more advantageous? Which one will take more space? What will be the space requirement for your adjacency matrix? The space requirement for adjacent matrix will be V by V, means vertex into vertex, because you are storing all the vertex kind of twice. It's a M by M matrix, or that you can represent as V by V, vertex by vertex. Okay, but in case of linked list, it's kind of only V, and you are just making the nodes. So space requirement for the adjacent matrix is higher, and normally uh, like graphs, like while don't have like too many connections, adjacency lists are always better choice for most tasks. I'm not saying like always adjacency list is better, but for most of the tasks adjacency list is a better choice, because adjacency list takes more space. Okay, is it clear? The cones of adjacency matrix. Okay, okay. So everyone is clear. So I won't go to the other. There are two more topics. Then your whole syllabus is finished. Two graph traversals are there. One is depth first search, another is breadth first search. So these topics I'll finish today, or just one day is sufficient actually. We'll see. I can just, means this week your syllabus will be finished. Okay. So I'm ending the class here. If you have any doubt regarding the graph representation, you can just tell me. Anyone has any doubt? Will ask it. Others?
No, ma'am.
Okay. Okay. Good. So I'm ending the class here. Just stop sharing and just take attendance. Okay. Thank you. I'm ending the meeting now. See you in next class.